Hi guys, this is GK from GK Marine Tech. Today we are going to discuss about power factor. What is power factor, which is affecting the power factor, and how to calculate the power factor, and what are the significance in the power factor calculation, and we will see this lesson. So before going to this lesson, this waveform behavior, current waveform behavior due to inductive load, what is happening, last lesson also we discussed about this. You see that reference to the voltage curve, the current curve is lagging, delaying due to the inductive load. Okay, so capacitive, I told you capacitive is only for improver, so we are not taking this a capacitive load, we are taking only pure inductive load. We are going to talk for understanding the PF. Okay, so in inductive load we know that the current is lagging some degree, that degree is known as phase angle, and cos of that phase angle is called power factor. This one last lesson we discussed. Okay, so what is happening if it is delay, then power calculation, what will be happening, we will see. So for power calculation, I took it on example, one inductor, one resistive load, and the AC system, AC source. We are not going to talk about the DC source, only we are going to talk about the AC. AC only this PF and everything is coming. So AC source, because why I took it both together, all the inductive load is having some amount of resistive load also. Without resistive load, inductive load will not come. That is why for calculation purpose I put it both. So because of this inductive, because only pure inductive load, the lagging will be 90 degree. Because of this resistive load, it is somewhat below 90 degree. So that we can, calculation is very easy. Okay, pure inductive load will not be there. Always along with inductive load, some resistant load will be there. Okay, now you see that this is the curve, lagging curve. See, voltage curve is starting from the center point and 0 point, and then after some time, after some delay, the current curve is starting because of the lagging inductive load. Okay, so now we are going to calculate the power. Power formula, what is that? V into I. Power formula is V into I. So what I am going to do, this I am going to divide a lot of points in between these lines up to one cycle. Okay, one cycle I will measure current and voltage in the same point, and power equal to V into I formula I am going to multiply, and this P value I put it here. P value I put it here. So I am going to make one power curve with these two curves. For that I am dividing this curve into equal parts or non-equal parts. It's nothing. We are not going to take average or RMS value. So we can divide how you can do it. We can do it because we are going to finally we are going to plot a curve for understanding purpose only. Okay. So now what we are doing, we are finding out this instant voltage, instant current in one point, same point. We are multiplying these two values and plotting in the power diagram. Okay, but here what is the problem? Here voltage is plus, current is minus. So minus into plus, the value will become minus, right? So the minus power, the power will be in the minus. Power will be in the minus. See, now I am going to take another point. Another point will be here 0. Even that time voltage is there, but current is 0. So the value also 0. There is no plus, no minus. See, even voltage is there, but no power, no current. So here 0. Now you see the other point. Both are in plus. Both are in plus. If you multiply, you will get the positive value, maximum value. And then again you will take it to this point. Both are in plus only. Same value, not same value, it is crossing, but that is no, amplitude is different. So this both we calculated. Here maximum current is there, but voltage little bit low. But even it is the positive. Power in the positive. Positive means this is the datum line. Is above this is a plus power, positive power. Below the line is negative power. Okay, so now I will take it to another point. This point current is there, but voltage is 0. That's what I said. If you stop the voltage also, some current movement will be there due to the momentum of the turbine wheel. Last lesson example I told you. So the current is still there. So now you multiply, but anything to multiply to 0, it becomes, the value becomes 0, that is why the power is 0. So now you take it in the minus side, not the minus side, between. In this between I took it, but here current is positive, but voltage is negative. Current is positive, voltage is negative. Again the power will become negative. Got it? So now again we will switch over to the next point. Here current is 0, but voltage is negative. So again the value will become 0, power is 0. Then now you see both are in minus, minus into minus plus, right? So minus into minus plus, the power is coming on the plus side. Very simple. Now you see, again it has become 0, we put it 0. Now like this we make a one same pattern how we are sine wave is there. It's not a sine wave, it is a multiplication, you are getting some wave. It's similar to sine wave only because these two are sine wave, that is why this is also coming like a sine wave. Okay. So in this, how we will draw one curve? We will draw one curve. This curve is called power curve. It's like a voltage curve, current curve is a power curve. So inside this power curve area, inside the power curve area, above the datum line or below the datum line, that area is called total power. So you have to calculate the area and then you can add it and you can. But now the problem is that you see what is happening. Some of the area in the positive side, some of the area in the negative side. That means what? It is representing what? Positive side means the source is supplying the power to the bulb and inductor, right? And this red color, it is below the datum line, it is a negative direction, means the power is not supplying, power is returned back from the inductor, because bulb will not return back any power, but inductor I told you it will return back some power. I told you why it is written. If you don't know anything, then you see the last video, I explained that. Okay, this inductor, it is storing the current movement in the form of magnetic energy, and then again magnetic energy return make the EMF back EMF and then giving back to the source. So one thing you remember, inductor always stores magnetic energy and capacitor stores always electrical energy. Both are different. So in this we can store the current, we can take back the current. Capacitor, we can store the voltage, we can take back the voltage. That is the difference between capacitor and the inductor. Okay, so now because of the inductor, some of the power is returned back, but we are giving total power, but this power is not doing any work. It is just returned back without doing any work. This cannot be avoided, we can minimize. Okay, so you have to calculate the how much portion is waste and how much portion the work done has happened. That ratio is called power factor. Efficiency, you can say, is energy efficiency. That is called power factor. You understand one thing, if it is an inductive load, it is like an inductive motor, then you are supplying the supply to the inductive motor and then running the inductive motor. That inductive motor will return back some amount of power to the source. It will come against to the source. That source, to compensate that returning source, we have to make more power, right? So here useful power is yellow one, this useless power is red one. This both we are producing from the AC source and giving, but this power is returned back. You got my point? Okay, now because of this only the power factor is coming in the AC system, that also due to inductive load. So capacitive load, what will happen? Capacitive load also it will do the same thing, but in the reverse manner. So that time this curve, how much lagging is there, it will lead. Only capacitive load, if you put it, the same problem will be there. So you cannot put only the capacitive. So we have to minimize this. You have to add the capacitor. So capacitor, what will happen? It will push the curve ahead. It will lead the curve. So it will compensate. So the capacitor should not be overrated also. So we have to calculate your power factor, how much is there. Accordingly, you have to put the capacitor. If you put more capacitor in the system, then the same effect will be there. Because of leading, this is because of lagging. Because of leading also same effect will be there. So the power factor calculation is a big task and it's a design. It's a big design. Okay. Okay. Now we will see how the power factor, because this curve we understand, but from this you cannot make a calculation, you cannot make a arithmetic calculation and designing and problems. So for that we have to convert this sine curve into single line curve. Before that, just for refresh, I'll tell you, this is the AC source giving the power to resistive load and inductive load. What is happening, you see, some of the current is going in the resistive load and glowing the bulb, making dissipate the heat and going off. It is not coming back. It done the work done. Okay, but some of the current, you see, it is going to the inductive load and it is returning back. This is what happening. So simple animation representation, you can understand this. Resistive load will not return back anything, but inductive load, it is a good item. It's return back some current. Whatever the extra, or it is always it return back some amount of current back to the source. So that is a problem for us to overcome. We have to minimize. It cannot be avoided, but you can minimize with your improve in the generator system, or you can add the capacity or synchronous motor. Okay, so this is the happening for the power factor. This is the reason for the power factor. Okay, so how much we are returning back and how much we are supplying, that is called power factor. So power factor equal to active power. Active power means from source to load. From source to load, that is active power. From after inductive load, it is returned back. No, the returning power is called reactive power. It is opposite to the active. Okay, so active power means source to load. Reactive power means load to source. So we have to make a percentage. How much actually work done happen? How much you supplied? How much you supplied? Active power and reactive power both you supplied, but the work done happen only the active power. So this percentage, this is the energy efficiency. This energy efficiency, see, so this energy efficiency is called power factor, and this total power we are not always adding both, no, active power, reactive power, active power, reactive power. So the addition of active power and reactive power, we are calling it as apparent power. Active power is source to load, reactive power load to source, apparent power is active power plus reactive power, total power. Got it? So this is the terms we are using: apparent power, active power, reactive power. The units are different, the instrument we are using for measuring is different, and how to calculate. If you know two, you can calculate the third one. Okay. So how you are going to calculate? Simple idea I will give you. Definitely it will be very helpful to you. Okay, now we see phasor diagram. Phasor diagram is that same sine wave. It is having a lot of variations in the voltages, and it is a lengthy diagram. So for easy understanding, easy calculation, and use of basic arithmetical method of calculation, we are converting the same diagram, sine wave diagram, into phasor diagram. Phasor diagram or vector diagram used to call. This diagram, what is that? It is having not only magnitude, it is having the direction. Okay, you understand one thing? Vector means it is having magnitude and direction. What is direction? See, for example, if any movement is there, we can say that it is moving. If a train is moving, we can say that train is moving. That is a scalar quantity, not a train is moving from this point to that point. But if you say train is moving in the northern side, or train is moving in the southern side or northwest side, then you are mentioning along with that one more direction, vector. So that is why we are calling it as a phasor diagram or vector diagram. Okay. So this phasor diagram, what we are doing, all the current, we are, see, voltage we are not doing anything, because voltage is a reference. Voltage we are not going to do anything. With the reference only we are checking the current, how much is delaying. It is lagging or leading or in phase. Okay, so we have three loads. This time I put it three load for understanding. I put capacitive load, I put inductive load, I put resistance load, and I given a AC source. So three load in series. So resistance in series, current in series, you have to add, right? So we are going to take each equipment, each part, how much taken the current. Inductive, it is taken current IL. Capacitive, it is taking current IC. Light, it is taking a resistive load, it is taking current IR. But all three are current only. All three are current means you cannot add directly because their direction is different. See, if so for example you are telling I am going north side 10 kilometers and south side 5 kilometers. So total how much you traveled? So 10 minus 5, right? So if I directly add 10 plus 5, it will become 15 kilometers. You walk to 15 kilometers, but your direction is in the reverse direction, so you have to minus it. This is the vector addition, vector calculation, phasor calculation. So that is why we have to put the direction also, very, very important. Pure inductive load will be in the downward direction because this is the voltage, current will be lagging. This is the voltage curve. Okay, resistive load in phase, there is no lagging. So both the direction I put it same direction. This is the resistive load current and this is the voltage. Voltage is common for all three current. Okay, now inductive load is 90 degree lagging, from voltage 90 degree lagging. Because always the phasor diagram anti-clockwise, counterclockwise only the phasor diagram will be rotated. So this direction if it is rotating, this is lagging, correct? This will become late. So this is I put it downward direction, this capacitive I put it in the opposite, it will be leading. So that is why I put it in the upward direction, 90 degree. This is a pure capacitance, pure inductive, pure resistance. I divided all three into the separate parts, pure inductance, pure capacitance, pure resistance. All three current I plotted in the phasor diagram in as per the direction. So now voltage I drawn horizontal, that is a base, and resistive current I put it horizontal, and resistive current for the due to the capacitance I put it vertical, and resistive inductive current I put it in downward. Now what we have to do, all three current you have to add, all having different values. How to add? It is very, very simple parallelogram method, or you can make it as a triangle, and you can use Pythagoras theorem, trigonometry theorem, anything. It's just like a max now. You put it a line. The line is measuring that current value. So now it is like a max only. Geometry only. So you can easily calculate all three. If it is, I will tell you, now it is the upward direction, this is a downward direction. Downward direction is more current, right? So what I am going to do, downward direction, I am minusing the upward direction, like this. Downward direction current, I am going to minus the upward direction current. That means IL minus IC. IL minus IC, it will become this much. So IC is gone now. Because I eliminated, I differentiate with these two current, I put the resultant current here. So that is the final current due to the reactance. I put IL, but it is a reactance. Because IL is more, that is why I put it IL. It is a reactance current. Okay. Now you got two currents now. Reactance current, resistive current. These two currents, you have to make a resultant. You have to add phasor method. Okay. So what I am doing, for easy method, you have to shift this vertical line to the other end. I am making the hypotenuse line, slant line, like this. This is a easy method. Trigonometry method is a triangle method. Why I am telling this triangle, few seconds we are going to discuss. This is called power triangle or PF triangle, whatever it is. That one we are going to discuss. That time you will get confused. That is why I have shown you now how the power triangle have drawn. Okay. Now this is the actual current. That means source. This source, how much current is supplied? This is the current. Now we got V and I, but still I is not in phase. Correct. So we are having now two powers. One power vertical side, one power horizontal side. Because it is in the slope. Slope is always having one vertical, one horizontal. That's why it's become slope. If vertical is not there, the line will become horizontal. Horizontal is not there, line will become vertical. Both the components are there. That is why the line is horizontal in slant position. So what I am going to do, I am going to measure this height. That is a vertical height, and I am going to measure this height. So we have two powers now. If you multiply that current into V, you will get vertical power, horizontal power. So what is vertical power? What is horizontal power? You see, this angle is called power factor angle. In a few seconds I will tell you about that. What is that angle? This angle you can calculate by the trigonometry theorem, or we can easily calculate it because if you know the sides, you can calculate that angle. Okay, this is like a max only now. So now what I am going to do, this is for calculating this height. I have V I have Vi only, but we cannot multiply V into I, right? V into I means this line, but now I want the vertical line. So what I did, Vi sin theta. Sin theta is opposite side by hypotenuse as per trigonometry. So opposite side I want means I have hypotenuse, that is Vi. So Vi into sin theta. Vi into sin theta. Same way we can calculate this side, Vi cos theta. This is Vi. This is Vi. This is actual we are supplying. But this one did the work done. This one it didn't do any work. This is a worthless power. This is a reactive power. This is returned back to the source. So this work done is useful power. We have done the work, but this is nothing done, and it returned back to the source. Now you got the idea. Very simple, very easy to understand. Don't get confused, and a lot of theory says some statements maybe it may confuse you, but this is the basic. Okay. So now what I am going to do, this is called apparent power. Apparent power is called actual power. I will tell you what are the terms we are using for these three powers: apparent power, reactive power, and active power. Okay. So this is active power, which is going to do the work, and this is reactive power, which is returned back to the source. Okay. So now power types, three types. What are the types we saw now? Active power. Active power, the term letter we are noting. This is all very important. A lot of diagram or your manuals and all, they are mentioning these letters. Don't get confused what is that power. Okay. Apparent active power is P. Active power is P, which is going to do the actual work. Okay. Its other names are real power, true power. Another name is there wattful power, and actual power. And this is based on resistance. Correct. This is a resistive load. This is due to the resistive load. This active power is there. So that is why we can compare this one to the resistance also. So sometimes we can use the same formula for the finding out the value of resistance. Okay. So its unit is kilowatt. Watts or kilowatts. Unit is watts or kilowatts. Okay. So next one, reactive power. The opposite direction of reactive power. Reactive power is returned back as power to the source. The letter mentioned for the mentioning this reactive power is Q. So P is active power, Q is a reactive power, and other names of the reactive power is wattless power, phantom power. Phantom means it is hiding, it is vanishing, it is not showing anywhere, it is missing somewhere. Okay, that is why phantom power, and this is due to the reactance. So we have to minus, and the difference should be the reactance. Maybe it is the minus side or plus side, whatever it is. Okay, so this is the terms we used to call for the reactive power. Okay, so this unit is kVAR. This is a famous unit. This is a very important for induction motors. We have, when we are ordering the induction motor, sometimes this kVAR rating is very important. If it is kVAR rating too much, then you will face a problem in the generator. Generator, what problem you will say? Suddenly if you start the motor, so much dip will be there. So the kVAR rating is very important. Not only kilowatts, the kVAR rating also very important. Okay. So next one is that apparent power. This is actual power. The letter noted for this is S. Okay. The S is mentioned that apparent power. Wherever the letter S is there, that is actual power or apparent power. This apparent power is a total addition, phasor addition, not a direct arithmetic addition. Phasor addition of these two power and apparent power you are getting. Okay. So the other terms, total power, and one more thing you understand, this apparent power, it is Vrms and Irms, apparent power. So actual power, it is different. If you know the power factor, you can find the actual power. So the Vrms, Irms means your multimeter or your wattmeter, something, it is a display in the meter, no? That meters all you are giving RMS value only. If you are calculating the power from that meters, that is giving apparent power only, not the actual power. right? It is giving apparent power. How much voltage source is supplying, that much only you can calculate. But you don't know how much exactly the motor is drawn. For that, you need a wattmeter. I will tell you in few seconds. So the unit of this apparent power is kVA. This is also famous unit. They are very much confusion kVA and kilowatt. Even engineers are very much confused in this. Some of the ship they have kilowatt meter and power factor meter. Some ships they have kVA meter. Some ship they have kVAR meter. In future lessons, I will tell you if it is difference between the generator to generator, kVAR and all, then how to adjust it, everything we will discuss. Initially, we are talking about the basics. Future videos, incoming videos, so we will discuss about the how to tackle that problems in the ship, peculiar problems. Okay, for make it easy, we are making one triangle method. Triangle method means you can use Pythagoras theorem, trigonometry theorem, anything. You can find out if you are getting, you see, having triangle having normally three sides, you know. Triangle is having a three sides. Kilowatt will be in the horizontal in phase, and vertical will be the reactive power. The hypotenuse side will be the kVA. This is the power triangle, and this angle between kilowatt and kVA is the phase angle. That angle, if you take it cos value, then that is called power factor. Power factor is a ratio, percentage, so it is not having any unit. Okay, so this power triangle is very easy single line diagram. This is called single line because this is a sine wave, very difficult to calculate. So that is why they are marking this phasor diagram very easily to calculate. If you know angle and this one, you can find out this, you can find this. Four items are there. Any two is there means other parameters you can easily calculate. Got it? So now this is a power triangle, but this we are using the powers three sides. This is the apparent power, actual power, active power, reactive power. The same one we can put it in the resistance, inductor, reactance and impedance. Last lesson I explained about the what is impedance, what is reactance, what is resistance. The same because this is depends on the impedance because total resistance and inductive load total. No? So this one purely resistance, this one purely reactance. Reactance may be due to inductive or capacitive. Okay. So now we will discuss about more in the triangle. So power factor triangle, this is having a two triangle actually we are using for the power factor. One is using the power, kilowatt, kVAR and kVA and this angle. So in this triangle you have any two parameters, remaining two parameters you can easily calculate. So the same power triangle, same degree we can use for this resistance, reactance. I put it to inductive reactance, but you can put any reactance. Reactance and Z. Z is the impedance. Impedance is the total phasor addition of this both resistance and the reactance. So both are same only. So this phase angle will be here also same one we can applying for here also. So which calculation you want? You are doing the calculation the power side, power triangle, power system or power problem, then you can use this triangle. If you are using the resistance and inductive and impedance calculation, then you can use the same one. So power factor can be calculated by two triangles. One is this impedance resistance triangle, one is a power triangle. Got it? Okay. Next, this is by Pythagoras. One more thing, Pythagoras theorem, you heard about it. Trigonometry, Pythagoras theorem. Pythagoras theorem means if it is three sides are there, this horizontal side square plus vertical side square equal to hypotenuse side square. A square plus B square equal to C square. This you know about it. So by Pythagoras theorem, you can calculate kVA. How to calculate kVA? Kilowatt square, root of kilowatt square plus kVAR square. You cannot add directly because it's a simple right angle triangle, right? Right angle triangle, the formula A square. This is A square. A square equal to B square plus C square. So same way we are telling, is because of square, we want the square root, so we make it a square root. Kilowatt square plus kVAR square. Very simple. Here, same one, Z equal to R square plus XL square. Got it? Same. How we are calculating this triangle, the same way trigonometry, Pythagoras theorem, we are calculating. So this all we have to be very careful. If you are doing any exam problems and all, then you have to use this kind of formulas carefully. Make sure all the units you are putting right. Okay. Power factor. Now from this triangle, you have some parameters and you have to find this phi, phase angle. If you know the phase angle, you put cosine of the phase angle, you will get the value, how much power factor, that may be 0.9, 0.92 like that. That is equal to kilowatt by kVA. If you have a kilowatt and kVA, you can find directly. Cos phi you can find directly also. Like that, if you have a R and Z, you can find out like this. You have impedance, you have resistance, then you can easily cos phi equal to resistance divided by impedance. So very simple. I think this complicated subject, it will help out the animation. I explain very simple, basic manner. Definitely, I hope nothing confusion for you. And if anything is there, given the comment, and in future videos, I will add the explanation for that in the future videos. Okay. So I hope you understand. Now, one more. Normally, regarding this power factor, the famous picture is this. So all institute, they will show this picture. Is some Pepsi with foam. So they are telling this full glass, the shopkeeper will charge you. That is the actual power they are spending. But you drink only this quantity is useful to you, and this foam is waste. So this is a very easy, simple example for understanding reactive power, active. This reactive power, because of this only reactive power happens. When you are pouring, no, so the gas is formed, so that the reactive power, it is not going to do any work. After some time it will vanish, and this power you are going to drink, that is a useful power, and total power is the apparent power. So for just for remembering, this picture is very helpful. Okay. Another one, multimeter. I already showed you multimeter, ammeter, whatever it is in the panel. That will give only RMS value. So with the RMS value, you can calculate only the apparent power. You cannot calculate actual power. Actual power is a kilowatt. So if you want to find out the kilowatt, you cannot calculate the volt into amp. V into I you cannot calculate. V into I calculate, you will get the apparent power. So you have to calculate the kilowatt. Kilowatt is the actual power which is done the work. So for that, you have to use the kilowatt meter. Okay. Kilowatt meter will give directly the true power. That is actual power. Now you got the idea. So don't get confused. Multimeter, you check the voltage and I, and you are checking the kilowatt what is rated in the motor. That is why I said this mistake normally people will do. Their multimeter they are checking how much voltage, how much current is taking, tongue tester. They are measuring the amps. And they are multiplying, they are telling this motor is drawing this much current. No, that is not telling. Actually kilowatt you have to multiply by the cos phi. Otherwise you have to use the kilowatt meter. Got it? So this, I think this is enough for this regarding this power factor. And the next lesson we will go for the 3-phase AC system. That is a very important one. How to calculate the power in that and how it is working. Single phase and 3-phase, how it is differentiated, how it is working, what is the purpose of 3-phase in AC system. DC nothing, there is nothing is there, only DC plus minus, that's all. But AC we have this many, single phase is there, 3-phase is there, and 3-phase center isolated earth is there, earth point is there, so neutral point is there. So everything we will discuss about in the next video. We will see soon in the next video. Thanks for watching.